Purdue Research Foundation Office of Technology Commercialization moves Purdue innovations to the public. Among these innovations is an adhesive inspired by how shellfish affix themselves to rocks and boats. The technology was developed by Jonathan Wilker, professor of chemistry in Purdue's College of Science and professor of materials engineering in Purdue's College of Engineering.
Adhesives are all around us. They're almost everywhere that you look, from gluing the carpet down below our feet to gluing our shoes together. Our furniture is very often glued together. And the adhesives that we have right now are great in many regards, but there are some difficulties we have with them. So one is that most adhesives we have don't really work well in wet environments. They can be toxic, they can be releasing volatile organics into the environment, and most of them are sourced from petroleum, and really we'd like to be getting our materials from renewable feedstocks. So we're in need of new adhesives for lots of different applications. One that comes to mind right away is in the biomedical sector, where if you have a surgery or an injury, we basically put you back together by sutures and staples and screws. These are just inherently traumatic to the tissue. You'd be a lot better off if we could glue your tissue back together, but right now we don't have the ability to do that because the adhesives we have are toxic, or they don't set wet, or they don't make strong bonds.
Wilker's research group, which is part of Purdue's Department of Chemistry and School of Materials Engineering, is testing and developing a new material inspired by Wilker's experiences scuba diving.
We work with the animals, we try to figure out how they make their adhesives, what the adhesives actually are, and then we take that information and we use it to develop synthetic mimics of the biological materials. Shellfish like mussels and oysters make really intriguing adhesives, but we're never going to get enough material from the animals themselves to develop any applications. So what we do is we take the characterization insights that we develop by working with the animals, and then we translate that into synthetic systems. And so then we make biomimetic adhesives based on what we learn from the animals. If we do our design right, we can make adhesives that are sourced from sustainable feedstocks. We're shown that we've been able to make these materials that have a very, very strong bonding, and they can set underwater as well.
Wilker's group has created platform technology adhesives that could be developed for applications in several sectors, which will require industrial partners.
Our lab's been very fortunate to receive funding from the Office of Naval Research and the National Science Foundation. And some of the major aspects of the work that's been funded is trying to understand how the animals make their adhesives and what their compositions are, trying to develop synthetic mimics of these natural materials, and also actually trying to develop surfaces that the animals cannot stick to for making coatings for ships. So far, what we've done is develop what I think is a very exciting series of new materials, and so we have adhesives that can bond more strongly than established commercial glues that you find in the store. They can set in wet environments. It's going to have to be developed into different directions to address different markets, and so if we want to go in a biomedical direction, we might be partnering with one group. If we want to talk about construction of cars in another group, airplanes in another group, and maybe even cosmetics would be into a different direction with different people.
Purdue University's patented technologies include new cancer treatments, alternative fuels, biomedical devices, agricultural innovations, and others that are available for licensing through the Office of Technology Commercialization. For more information, email innovation@prf.org.